In this video, we are going to look at writing linear and exponential equations from tables. So first, let's look at the difference between linear and exponential functions. Looking at their graphs, a linear function has a constant rate of change, which is going to cause it to be a straight line. Exponential function is going to start off flat and then increase very quickly or exponentially. It can also go in the opposite direction, where it decreases very quickly and then flattens out at some point. For a linear equation, the equation is y equals mx plus b, where m is your slope or your rate of change, and your b is your y-intercept, which is where it's crossing the y-axis. If you're looking at a table, it's going to be the y value where x is equal to 0. For an exponential equation, we have y equals a times b to the power of x, where a is your starting amount or your y-intercept, and your b is your change or your ratio. If you were looking at their tables, for a linear function, you want to look at the first differences. If they are all the same, it's going to be linear. If you are multiplying by a common value or a common ratio, it is going to be exponential, and that's going to be your b value. Okay, so we are going to look at two examples for each one of these, one where 0 is a part of the table and one where 0 is not. So first we're going to determine what kind of function it is. And we're going to do that by looking at the differences first. So on the top, we can see that it's adding by 2 every time. And on our y's, we have 2 negatives and 4 positives, so that's a total of 6. From 4 to 10, that's another 6. And then we can see that these are all adding by 6. So we can see clearly that our first differences are the same. So that means that this is a linear function. So we're dealing with y equals mx plus b. To find your m value, this is the difference of the y's or the difference of the x's. That's where we get that rise over run. So we already know what those differences are. That's what we found over here. So the difference of our y's was 6. The difference of our x's was 2. At this point, if you can divide evenly, go ahead and do that. If not, you would want to simplify that fraction. So 6 divided by 2 is going to give us 3, or 3 over 1. For our b value, that is our y-intercept. So we said that that is the y value where x is equal to 0. So we're going to find where x equals 0. The y value is going to be your y-intercept, so that's your b. So we have everything we need. Y equals our m, which we said was 3, x plus our b, which we said was 4. If you wanted to check if your answer was right, then you could pick any x value that's in your table, plug it in, and make sure you get the y that's in the table. So if we took 2 and we do order of operations, we're going to multiply first. 3 times 2 gives you 6. 6 plus 4 gives you 10, which is what's in the table. Okay. So now we're going to look at what do we do when 0 is not in the table. Okay, so first we're going to check to make sure we can tell what kind of function it is. So on the top, we can see that these are all adding by 1 every time. On our y's, these are going down, so we're subtracting. So 27 to 24 is 3. And then we can see that they're all 3. So this is going to be linear because our first differences are the same. So we're dealing with y equals mx plus b. So our m is the difference of our y's over the difference of our x's. Okay, so we found that the difference of our y's is -3. Difference of our x's is +1. So when we divide -3 by 1, we just get -3. When we go to find our b value, normally we would look at where x is equal to 0, but we don't have that. So what we're going to do instead is we're going to pick any x and y that go together. We're going to plug it into the equation with the m that we already found, and we're going to solve for our b value. So I'm just going to pick these two right here. You can pick any set. They're all going to give the same answer. So the y that I chose was 27. The m that we found was -3. The x that I chose was 49. And then plus b is what we are solving for. Okay, so what we're going to do first is that multiplication. So we're going to take 49 times 3. 9 times 3 is 27. 3 times 4 is 12, plus 2 is 14. So we're going to get 27 equals. And then a negative times a positive gives you a negative. At this point, we have a one-step equation. We want to get b by itself, so we're going to do the opposite of what we have here. So this is negative. The opposite would be plus. So we're going to add it to both sides. Okay, so these cancel out. I'm going to write it over here. So we get b equals, and we're going to add this together. So 7 plus 7 gives us 14. 4, 5, 6, 7, 1. So b equals 174. Because I could have written it right there. And we have everything we need to write our equation. So we have y equals our m, which we said was -3, x, and then plus our b, which we said was 174. For our next one, if we look at our y values, we can kind of see that these are increasing really fast. So a good place to start would be to check if it's exponential first before we start looking at the differences. So on the x's, we do see that these are all increasing by 1. Right? And then we're going to check the y's to see if we're multiplying by the same value. So we can see that 2 times 3 is going to give us 6. And we just want to verify that that works for all of them. So 6 times 3 does give you 18. 18 times 3 gives you 54. And 54 times 3 gives you 162. So we're good to go. This is exponential. So we have y equals a times b to the power of x. We said that a is the start for the y-intercept, and b is your change. So our b is the change that we found right here, our ratio, which is 3. Our a is our start, our y-intercept. So this, just like the y-intercept for the linear ones, we're going to find where x equals 0. The y value is what we're looking for. So with that, we have everything we need. So you can go ahead and write our equation. Y equals our a, which we said was 2, times our b, which we said was 3, raised to the power of x. And again, you can pick any set of points in there to plug in and make sure you get the right answer. So if you pick 2, 3 to the second power is going to give you 9. 9 times 2 gives you 18, and that's what we wanted. So we're good to go. On the last one, we are going to do the same thing like what we just did. So we can see our numbers are increasing. So a good place to start is to check if it's exponential. So 8 times 2 gives you 16. And we just want to verify that the rest works out. So 16 times 2 gives you 32. 32 times 2 does give you 64. So this is correct, and it is exponential. So we're dealing with y equals a times b to the power of x. Okay, so now we're going to find each part. So remember we said up here that our b value was our change. So that's what we already know. We said that that change or that ratio is a 2. So b equals 2. Now we need to find our a, which is the starting point or the y-intercept. And we said that that's going to be where x equals 0. When we look at our table, we don't have that. For this one, it probably would be simple enough just to go backwards and divide to get that number. But we're going to do it with doing all the math just in case you have numbers that are higher and you need to know this method. So we are going to choose an x and y to use. We're going to plug it in with the b we already know. We're going to solve for our a value. So I'm going to choose the first one. You can choose any set. X. Okay, so the y value that we chose was the 8. Our a is what we're looking for. We said that b is equal to 2. And the x that I chose was 1. Okay, now we're going to do the order of operations. So we're going to do 2 to the first power, which just gives you 2. And then we are looking for a, so we want to undo that multiplication. So the opposite of multiplying is dividing. And 8 divided by 2 is going to give us 4. So we just found our a value. Now we're going to put that together to find our equation. So y equals 4 times 2 to the power of x. And that's it.